Welcome to a What's New in Hyperlinks DRC VX 2.8 video showcasing the 5 new IC packaging rules that are included out of the box. The first new rule is focused on the acute angles in an IC package. In package designs, acute angles are manufacturing showstoppers. If the angle is less than 90 degrees, it is possible a teardrop can't go in and the PCB will have repercussions when fabricated. This rule will point out the angle and the location in the design where it finds the violation. Natively, a PCB layout tool would not detect them, and these types of acute angles would be found during the manufacturing sign-off. Hyperlinks DRC shifts this check left and allows our customers to find them and correct them before sending it to manufacturing, and removes the needless back and forth iterative checking process between the layout designers and manufacturers. The second and third new IC rules are copper focused. They are the copper density adjacent blocks check and the copper density walking blocks check. In a package, substrates can be 3 to 5 microns thick. So if the copper density per area is too far off, you will have warping, and in some extreme cases the substrate can fold in on itself. The adjacent and walking copper density rules indicate on the package design layer where there is a large copper disparity in a design, which has a chance for that layer to warp. There is a parameter built into the rules for the block size that checks overlapping in the design across the layer and looks for any gaps or voids, etc. where there isn't a lot of copper by design. It indicates where that warpage can occur. If these checks are flagged, you may move some traces or routes around to correct it in the layout. Notice this walking block check is finding a Swiss cheese area of the PCB that is not meeting our minimum distance check for copper. The fourth new IC rule is max solid copper area. This rule automatically scans and finds the solid copper areas in your design. This is important to know because solid copper does not allow gases to escape during the manufacturing process, which can cause delamination in a package. Because in package designs, relative to larger PCB designs, you're not always able to follow the same manufacturing processes. In packaging, everything is so small that it's impossible to do an acid edge on, let's say, a 10 micron trace. There would be integrity issues. So then an additive process is typical for traces and vias in package designs where you add copper back into the laminate. This process requires a predefined pinprick to pop all of the introduced gas bubbles during that additive process, which is called the degassing hole. This max solid copper area rule shows the predefined area and tells the designer that they must have a pinprick here or there will be problems. The last new rule, the Offset Outgassing Void Check, takes this idea a step further. For example, if your design has to have outgassing voids on 3 layers, what if there's a trace on the 4th layer that runs over that void? When manufacturing outgassing processes occur, these voids can change the impedance of that trace, causing signal integrity problems. There might even be no plane underneath that trace now. Typically, designers will place their outgassing voids shapes and make sure that they are offset from the odd and even layers of the package so that none of them line up, creating these inconsistencies. This rule checks the design to see if any 2 layers have a hole bigger than the specified XY distance that you can see through 2 layers. The lit up areas of these violations show where the crosshatch doesn't line up. Hyperlinks DRC now contains these 5 IC packaging rules out of the box, left shifting some of the final sign-off checks to the design cycle of a package layout in order to check and correct problems before a prototype is created. These new rules are made as an automated first pass check before sending the board to the final manufacturing stage, where sign-off with Valor would occur, or the final packaging sign-off with Caliber, our other best-in-class Siemens EDA tools. By catching the majority of the issues up front, we can easily correct them and have peace of mind going into our final PCB design stages, and run checks more often throughout each stage of the PCB and package design cycle.